Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Here are the vectors for parts A, B, and C. Each is written as a column vector. Decide whether each set spans a line, a plane, or all of our three. Pause and think. If you don't know yet, you'll feel great when we reveal the reasoning. For part A, we compare the two vectors and see that the second is 3 times the first, so they are linearly dependent. All linear combinations are scalar multiples of v1, so the span is the line through the origin in the direction of v1. So the span is a line through the origin in the direction 1, 2, 3. In part B, we form a linear combination A times z1 plus B times v2. Note the x, y, z components in terms of A and B. Eliminating the parameter b yields the linear relation 3y equals 2z, which describes a plane through the origin. Because every linear combination equals a 2b 3b, eliminating parameters gives 3y equals 2z. The two independent vectors lie in and span that plane through the origin. Art C asks whether 3 given vectors are independent. We write the system for A, B, and C so their linear combination equals the 0 vector. Subtracting equations shows C equals 0, then B and A are also 0. Only the trivial solution exists, so the vectors are independent. Since the only linear relation is the trivial one, the 3 vectors are independent and together span all of R3. Let's recap our conclusions for each part. Part A. Both vectors lie on the same line, so the span is a single line through the origin. Part B. The 2 vectors are independent and span a plane given by 3y equals 2z. Part C, the 3 vectors are independent and together span the entire space. Great work! Watch the next video to learn more. There's always a fun geometric trick waiting.